Hello, Professor Sargent here with you again. We're going to take a look at solving polynomial and rational inequalities. The first one we have to solve is a polynomial inequality, and I'm going to do three things in a very specific order so that we do not have to do much different from other examples. So first of all, I'm going to divide both sides by -1, which will switch the direction as well. X cubed minus 3x squared minus x. And that will be less than -3. And then I'll add +3 to both sides. Now we've got a comparison to 0. And if we think of the left-hand side as a polynomial function, where it's equal to 0 would correspond to a graph of y equals x cubed minus 3x squared minus x plus 3 crossing the x-axis. So we need to factor this. You can make use of things like the rational zeros theorem and synthetic division, if you like. I think, though, we can factor by grouping on this. Turns out we can. And then that quadratic factor is in the difference of squares form. And so what would make it exactly equal to 0 would be -1, +1, and 3. Those are the only places that we could have a change in signs of what's on the left-hand side. That doesn't mean they will cause a change, but if there is a change, switching from negative to positive or positive to negative, these are the only values of x that will do the job. So I'm going to set up a sign chart looking in between these, as well as left of the smallest one and right of the largest one. All right, so I've labeled the three special values of x to make the left side equal to 0. And I've labeled the intervals that are in between these special values and what's to the far left and the far right. I'm going to look at what the signs of each factor are, and then use what we know about multiplying signed numbers to figure out the sign of the product along each interval. Now we know that +3 makes x minus 3 0. +1 makes x minus 1 0. And -1 makes x plus 1 0. Think of the number line where left of 0, you've got the negatives, and right of it, you've got the positives. That would be a sign chart for the factor x. So these other factors are transforming it. x minus 3 would transform this 3 to the right. It would shift it 3 to the right. So when we get to 0 at positive 3, everything left of that is negative, and what's right of it is positive. We're going to see the same pattern for x minus 1 and x plus 1. Whenever you have an even number of negatives, you're going to get a positive. When you have an odd number of negatives, you're going to get a negative. However, here we have a 0, as we do here and here as well. So it's the rest of them that we need to pay attention to. 2 negatives out of the 3. 1 negative out of the 3. And no negatives here. So what's going to be a solution to being strictly less than 0? We've got a negative here and a negative here. And so our interval is actually a union of 2 intervals, negative infinity to negative 1, parentheses at each, because you can't reach negative infinity for 1, and 2, there is no or equal to, so we do not have a square bracket by the negative 1. And the other one is 1, 3. Same deal, we don't have an or equal to, and so we'll have parentheses by the 1 and the 3. So there is our solution in interval notation.